Right, in this video we're going to look at rotating a function around the x-axis and getting this idea of a volume of revolution. Okay, so the question is if f of x is equal to square root of cos 2x, or x being between minus pi by 4 and pi by 4, is rotated around the x-axis, find the volume of the solid form. So if we just have a quick look at that for a minute, here we have the function that we need at square root of cos 2x between minus pi by 4 and pi by 4. We're going to rotate this round the x-axis. Later I'll show you what it actually looks like. So, in order to do a volume of revolution, you need to do pi times the integral from a to b of f of x all squared dx. So little a here will be minus pi by 4, and this be pi by 4. This is f of x squared, because it's like pi r squared, like the radius of a circle. Or, if we're using y, it's pi y squared dx. So first of all, you need to set up the correct integral for what we need to do. So the volume is going to be pi times the integral from minus pi by 4 to pi by 4 of the square root of cos 2x all squared dx. Now if you square root and square something, you end up with just the same function. So our integral will come down to pi, and then pi can come out of the integral sign because it's just a constant, from minus pi by 4 to pi by 4 cos 2x dx. Now if you integrate cos, you get sine. So if we differentiate sine 2x, we get 2 cos 2x using the chain rule. Now, so if I say that's my answer, I'm going to have 2 times too much. So I'm going to have to compensate that answer by putting a half in front. So the integral of this becomes pi by 2, 1/2 of pi. The half is from the compensation of sine 2x from minus pi by 4 to pi by 4. Next step is to put the limits in. So we've got pi by 2 sine of 2 times pi by 4 minus sine of 2 times minus pi by 4. And that's going to be equal to pi by 2. 2 times pi by 4 becomes sine pi by 2 minus sine of minus pi by 2. Now you need to know that the graph of sine at pi by 2 will give you 1. So that will be pi by 2 times 1 minus 1, which is going to give me pi by 2 times 2, which is going to, if we cancel out, we get an exact answer of pi cubic units. Now we can look at what this integral actually looks like. If we go to my computer here, and let's choose a rotating view, and we'll just start the function on, and you can see what happens as we go around, that it actually rotates around the axis. We get our shape here looking like that, and it acts sort of a ball. That's what, well, sort of an oval ball. That's what the volume of a revolution looks like. Now, if you want to look at your glasses, put your glasses on now, and to do that, you select this one, and then this one, and then glasses. And then if I just reset it and then do it, you'll get to see it in 3 dimensions. Okay. Right, some screenshots of what we've just done, the original function, and then the functions rotated round at different angles, have a look at it, like that. Now, if we want to do it on a paper 2, then we do it slightly differently. Now, for a calculator paper, we set up the correct integral. So you need to write down the correct integral. Pi from minus pi by 4, pi by 4 to pi by 4 is square root of cos 2x all squared dx. That's fundamental that you write that down. Oops. Sorry. Going to the calculator, selecting calculator mode, and then go menu. Sorry, before we do that, we need to put in pi. So go to the pi first, pi, menu, calculus, and then you want numerical integral number 2, and then you put in the limits here, so it's minus pi divided by 4 from pi divided by 4, and here we need to put square root, so control x squared of trig cos 2x, and that all needs to be squared, and then put the dx at the end. Press the arrow key, press enter, and you'll see we get the answer of pi numerically. There's the screenshots. Writing down the full calculator value that you get from the calculator with 3 dots at the end, and then rounded off correct to 3 significant figures. You can write 3.14 cubic units to 3 significant figures. For a calculator, this is what is expected you to write this out. Okay, thank you very much for watching. I hope this was useful.